Okay, so we are ready to place the wires on Evan and collect some data. So notice that we have the pack that all the wires are plugged into. All of the leads are labeled here, and they correspond to different wires. So what I'm going to do is just lay this sort of on his abdomen for now. I'm going to give Morgan half the wires. They're a little bit tangled, actually. There's your other two. So notice on the wires, again, they are labeled. These particular wires can go on two ways, so they can either clip onto a tab like so, or using the electrodes that we have that have the snap, we can plug the snap into this hole, lock it down. This is much more stable, which is why we bought these electrodes. When he starts exercising, there's potential for the wires to fall off, so this snap method of placement is going to allow for more stability. One more thing before we start putting them on, we're going to make sure all the wires are moving in the same direction, so we're going to try everything pointing downward. Again, that will enhance the signal conductivity. All right, so I have right arm here. These don't have to be placed on in any certain order. We're not recording anything at the moment, so we're just going to sort of put them on randomly. All right, so we'll just double check all the wires are all pointing downward. So now I always say this is the moment of truth. We'll see how effective Morgan is at placements as we now start our resting exam. Of course, I should have had his data put in ahead of time, so I'm gonna have to do that quickly. What's your age, Evan?
23.
We need to put on some stuff in. What's your weight in pounds?
155.
155? Height in inches?
60.
So there we go, we have a signal. So notice on this screen that all 12 of the leads are listed. They're kind of grouped together, so leads 1 through 3, AVR, AVL, AVF, V1 through V3, V4 through V5. We're going to get the frontal view of the heart from these 6, so we'll come back to that in a second. And then down here, we're going to get more of the transverse view of the heart. So usually the chest leads are going to look a little bit differently in terms of what we consider to be the normal EKG. And for the normal EKG, usually we would look at lead 2. So when we look at this one, we see a very evident P wave, sharp QRS complex, and a T wave. T wave is larger than the P wave, so it looks like everything is positioned properly, so that's good. Notice on the screen, this will tell us his heart rate. So this is giving us a real-time heart rate. It's going to be an instantaneous measurement. So right now his heart rate is 59. Rhythm is not being interpreted yet. Now notice all of this is because I just kicked the computer by accident. So anytime there is any jarring with the wires, the computer, you're going to get a lot of this artifact. And honestly, our EKG device is more of a resting device. So as he starts exercising, the machine is not going to be equipped to handle the movement of the limbs. So it's going to be a lot messier. We should, however, be able to interpret it pretty well. So for your numbers, for recording on the lab, resting heart rate, we can go with 56. We will get his resting blood pressure in a second. Morgan, maybe you want to go ahead and get his blood pressure for us? So his EKG rhythm, 2 things we're going to look at. First, what is his rate? His rate is less than 60, so that's something important to note. As far as his rhythm goes, it looks normal, right? Predictable, P wave, QRS, T wave. It's repeatable. Therefore, it appears his sinus node is in charge of his rhythm, but because his heart rate is below 60, his rhythm would be described as sinus bradycardia. So that's what we would write for his EKG rhythm in the supine position. We are getting his blood pressure here momentarily. So once we get his blood pressure, we will then have Evan stand, and we'll do that for 60 seconds. And then we'll get his resting heart rate and rhythm from a standing position, and then we will move into exercising. What'd you get, Logan?
Huh?
What'd you get?
Oh, I didn't get it yet.
So let's take a look at the strips again. So this device will suggest potential misplacement. So notice it's suggesting that V3 or V4 may be misplaced, which could be producing some of the inconsistencies that we see in the EKG. A lot of this artifact that you see here is because of Evans moving his arm a little bit while we're getting his blood pressure. So again, the more stable everything is, the more still the person is, the clearer the picture will be, and the easier it is to interpret, because once you start getting a lot of this artifact, it becomes very hard to interpret any arrhythmia that might be present. Now down here in the chest leads, you'll notice that some of them, particularly V1, has downward deflections. And if you think back to the lecture, we talked about the direction of the deflection reflects the way the current is moving in relation to the heart. So V1 is the only electrode that's on the right side of the heart outside of right arm, left arm, right leg, sorry. Which means the current in the heart is moving away from V1, and that's why we have negative deflections on V1. For the most part, every other lead on the left side of the body, the current is flowing toward that lead and that electrode. Therefore, we have the upward deflections indicating a positive direction of flow. What did we get there? Resting blood pressure in the supine position is
110/70.
110/70. All right, so let's go ahead and have Evan move to standing position. And while he does that, we're just gonna maybe swing this direction. Now, get a shot of that, Mitch. When he stood up and swung everything around, it gets quite a bit messy. So we're gonna have him hold very still here for a moment, and it's gonna stabilize mostly. We will just double check the wires to make sure they're all still pointing the way we want them to after he changed position. So it's looking good now. So let's go ahead and call his standing resting heart rate 68. Rhythm is again normal now that everything is stabilized due to him not moving anymore. It's predictable, repeatable. Rate is between 60 to 100, therefore his rhythm in the standing position is a normal sinus rhythm. That's what we would call it. And we will we'll take a pause briefly while we get him positioned on the treadmill, and we'll be right back for the stress test.